Renewable energy concept design. Cars have been in very high demand since the 1920s when Henry Ford made them commercially available to all members of the public, as they're the most convenient mode of transport from getting us from A to B. Now there are about 1.2 billion vehicles on the roads around the world, and it is estimated that by 2050 this figure will double. This is why it's become more important to produce cars that run on more efficient and green fuels. In 2011, the UK alone consumed 7.4 million tonnes of fuel, including petrol and diesel, which has produced around 593.6 million tonnes of CO2 emissions. Therefore, the need for green vehicles is increasing. For our engine, we decided anyone that needs a vehicle can be a user. However, we focus more on people who live in remote areas. So, what was our design brief and criteria? When coming up with our concept, we decided it was important that our product was cheap to manufacture, so it would be cheap for the user to purchase. Other than cost, it was very important to us that the engine designed was green and produced little to no greenhouse emissions. This is then how we came up with our concept for the car that is powered by electromagnetic induction from the movement of wheels of the car. So, what is the principles behind the design? According to Faraday's law, which states the induced EMF is directly proportional to the rate of change of flux linkage, we knew we could produce an electrical current to power the car by moving a permanent magnet within a coil, so that the flux lines, also known as magnetic field lines, would cut the solenoid, which is a coil of wire, inducing an EMF which causes the electricity to flow. But how is this applied to our engine idea? When the wheels turn, they cause a set of crankshafts to turn. The movement of the crankshafts will turn the magnet and make the magnet move in and out of the solenoid, inducing an EMF. When the circuit is complete, a current will flow, and this can be used to power the car. Some of the electrical energy produced will be stored in a battery, so that when the wheels are not turning, there will be a supply of energy to allow the car to start and stop. So why is this a good design? This vehicle does not run on fuels such as petrol and diesel, so the user saves around £300 a month, which is the average amount spent on filling up your car. We then have the social desirability. As this engine does not require combustion of fuels, there is a minimum risk of fire or explosion, and the vehicle is relatively light and mobile. With technical feasibility, the magnets and solenoids are fairly easy to maintain, therefore it will not need to be checked regularly. The neodymium magnet we would use in the engine will also lose a fraction of its performance every 100 years, which means it has a very long lifetime. So now let's look at the calculations. If we take a car with a mass of 1,500 kilograms, travelling at 300 kilometers per hour, we can find the energy for braking, which is equal to the change of kinetic energy. So using the kinetic energy equation, we can get about 52,000 joules. Then we look at the efficiency. We know 46% of the energy is used by the generator, 60% is converted to electrical energy, and 80% of the energy produced can be stored by the generator. So each time you brake, you gain around 12,000 joules. Hope you enjoyed watching this video which explained how our engine works. Thank you for watching.